Hello everyone, I am Ruchi Raundal, currently pursuing my Masters in Construction Engineering and Management from CEPT University, Ahmedabad. I am currently studying in semester 2, which comprises of construction project execution, monitoring and control. For our study, we had chosen a multi-speciality hospital construction. The project brief highlights the type of the project, which is a greenfield healthcare infrastructure, which has one building with two wings. The built up area for the project is 30,380 square meter. The site area is 5,700 square meter. The building consists of three basements, ground floor plus 13 floors, which takes it to the total height of 55 meters. The total project cost is 340 crores approximately, out of which the civil work is of 118.49 crore. The type of contract for this project is item rate, and the contract duration is of 18 months starting from March 2023 till September 2024. Further are the site key plan and site context of for the project, which has commercial tower, school on the either sides. Activities include pre-construction meeting, the mobilization schedule to set up the site, water and electricity requirement during the construction period, legal compliances under contractor scope, setting up of temporary structures that would be required during the construction phase, the equipments required, and the safety control practices followed on site. The labor colony is located 300 meters away from the site. It also has staff accommodation and a RMC plant next to it. For safety control, there is EHS policy on site, barricading work is done, an induction room has been provided, and a safety park is also present on site. Further, for pre-construction activities, the water and electricity consumption for the site are analyzed. The water requirement on site is 190 kiloliter per month with an average water charge of 44 rupees per 1000 liters, which leads to a water cost per month of 8,000 rupees. For electricity consumption, the requirement is 8,000 units for every month with an average electricity charge of 13.5 rupees per unit, which leads to a cost per month of 1,10,000 for the electricity. For the project cost, the breakdown has been analyzed, which has been showcased. The highest cost from the project cost is for reinforcement, which is 43.9 crores. The total project cost is 118.49 crores. The movement plan has also been studied for vehicles and pedestrians. For site layout planning, the existing site layout or mobilization plan has been studied, where all the zones are identified, that is the admin area, the steel shuttering yard, the scrap yards, the manpower movement and the position of tower crane, and also the entries to the site. From this analysis, a site layout is proposed with suggestions like location of the steel yard on site can be changed so that it comes under the radius of tower crane. The position of tower crane has also been shifted. There was no security cabin at the other two entries which has been proposed. The multiple site entries can be avoided for a better security and tracking. Same path for pedestrian and vehicular can be avoided and separate paths can be provided. The width of the main entry has been widened so that the movement of pedestrian and vehicles can be done smoothly. A parking has also been provided. Further, a 3D visualization of the site has been showcased, which shows the current stage of the project core-wise. A linear responsibility chart describes the responsibilities of personnel involved in organization for quality purposes, which helps to clarify who shares the common work and identify the activities. The methodology followed for preparing the LRC is the list of activities and deliverables, then the determination of stakeholders, and then determining who has the roles and responsibilities for the specific activity. All of this leading to a vertical analysis and a plus delta. The personnels involved from contractor side are project manager and QA/QC engineer. The LRC highlights the primary responsibility. Approval must be consulted, may be consulted, and must be notified for each activity. Various activities have been identified, which led to a plus delta analysis, which highlights that the quality assurance and quality control plan is prepared by experienced quality head and there is a well-defined responsibility amongst them. The method statement for all activities should be prepared before execution. An engineering team should be involved in preparation of checklist of execution are few of the suggestions. Assignment of core planning, the formwork planning, reinforcement planning and concrete planning has been studied. For concrete planning, the total quantity of concrete has been derived core-wise from the coefficient of concrete, which comes up to 22,222. The peak concrete requirement has been identified from the schedule, which is February month of 2024. The labor productivity has also been studied, which comes up to 1.14 cubic meter per man hour. The number of transit mixers deployed for a continuous supply of concrete during the pouring is 3 transit mixers through pump. Various lean tools were applied for the activities on site, one of which is form and delay survey, which is a method for performance measurement and improved productivity, which was done by measuring the frequency of delays that occur. The activity that we considered was shuttering of shear wall on first floor, which was conducted by 2 carpenters and 2 helpers. The activity was studied for a duration of 6 hours 22 minutes. Various delays were identified on site, which include foreman giving instructions to the carpenters, the helpers taking a water break, and the carpenter waiting for panel from the helper. Out of all these delays by all the workers, it was identified that the carpenter one had the highest waiting time and caused the delays, which was due to the redoing of reinforcement work, which took around 44 minutes. Another majority of delay from helpers was caused due to unscheduled break and talking to other laborers. Further, the total working and non-working time for each one of them was analyzed based on the delays identified, which led to proposal of a spaghetti diagram, which basically shows the routes for each activity, which can be one of them can be stacking of panels, which has been reduced by provision or using a temporary staircase that has already been provided. The cost for all the delays has been studied after determining the non-working and working time for each worker. The total wages for the studied duration is 1803.89 rupees, out of which only 1101.46 are the wages for working time, whereas 702.43 rupees goes to the non-working time, which can be avoided, for which we have suggested different lean tools. For example, identifying the root cause and visualizing the workflow and managing tasks. There can also be supervision of engineered done to reduce the idle time. To conclude, from the pre-construction activities, we were able to understand the legal permits that are involved in the initiation of the project, the requirements of water and electricity at the site, and the various components of site and their interdependencies understood. For site layout visualization, the logic behind the site layout and its organization was studied. The parameters that one must look upon while site layout planning was figured out. A critical approach was applied to apply suitable changes for better functioning of site. A plan was proposed based on the understanding of site critics. For the lean tool, which we used for man delay survey, a survey for performance measurement and for man delay was done for the activity of shuttering of column. The performance was assessed by quantifying the occurrence of delays in the workforce everyday routine. It was observed that the highest delay was by the carpenters of average 30% due to rework in reinforcement.